popular. Yeah, so xDS is a configuration format, basically, that helps setting up service mesh. It explains to a bunch of gRPC services how they can reach each other. It originated from Envoy, which is popular reverse proxy, popular in cloud deployments. But now it starts getting other clients, notably gRPC. So also, what is service mesh? And by service mesh, we mean just the collection of interconnected gRPC services. In your regular microservice architecture, you will have a bunch of services, and they often need to reach out to each other to get information. So it can be distributed in any way. You can have some services that are running in the cloud, some services running in private cloud. So there are no restrictions. So all services that talk together, they belong to the same mesh. And in this presentation, by xDS control plane, we will essentially mean the configuration server. So it's a server or collection of services, so the system. It's what gRPC services in your mesh will be talking to receive the configuration files, the configuration. So one thing that I will note here that it doesn't mean that you have just one single configuration server. You may have a bunch of services, configuration servers distributed geographically or in any other way with excessive capacity. It will still be considered a single control plane. Because in this presentation, I will mention second control plane, and that's supposed to be something completely different from the primary. And by data plane, we mean the components that actually send the actual data that users care about. And another component is bootstrap file. So when you start your instance, your service for the first time, it needs to understand how to talk to control planes. So bootstrap file will contain all the basic information, starting with the server address and so on. So what happens if your control plane goes down? Not just a single configuration server, but the whole control plane. So your services cannot get any configurations. So first of all, if you say have auto-scaling on your AWS instance or somewhere, new instances won't be able to talk to other services in your mesh. So you may get a new instance, but it won't be functional because it cannot get the other data it needs. But it can also impact the instances that were already running for some time. So xDS pushes updated configuration continuously. As your mesh changes, for same auto-scaling or for any other reasons, new services may come and go, and the configuration will update the rest of the mesh to explain how they can interact. So without those updates, so for instance, some server may need to talk to another instance, but the configuration is outdated and that instance is down, but it won't know about the new instance. So even already running instance may start degrading. And so it will impact the user. So the performance of the overall mesh will start degrading gradually, or maybe faster. It depends. Yeah. So, yeah. So now the feature that I hope nobody needs, xDS fallback. So the idea of the xDS fallback is that there are more than one control plane deployed. And if the primary server that is usually used goes down, then the mesh will try to use the backup data. So this should solve most, if not all, the problems outlined before. So one problem is that the control plane may not be a trivial system. So as I mentioned, it may be a bunch of instances. It may be distributed geographically. It can have some data store. So fallback requires a complete secondary control plane. And this means that it may be costly to maintain it. So we don't expect the secondary control plane to have the same availability as the primary one. So it may have stale data. It may have less instances, less control servers available. And if the mesh will suddenly jump on fallback control plane, it can cause denial of service attack, basically. Like if all the services at once try to fetch new configuration. So this is one of the problems, but also, as I said, the data may be stale there. Okay. So this is why we don't want to always jump on fallback control plane, and we try to use the data that we assume is better from the primary control plane. So another implementation detail that I should have mentioned before is that xDS configuration is not monolithic. It's not like a single JSON file that contains everything. But instead, it's a bunch of interconnected resources. And by resources here, we mean technically they're like protobufs, but it's several files, and they can be updated separately. So as a new cluster comes up, then only some resources will be updated, and then the rest of the servers will be able to use it. So there is no need to re-download it all the time. But if you are talking about fallback, if you are talking about having more than one control plane, this can also be a problem. That we need all resources to be from the same control plane, because otherwise we will have so-called config tears. And to avoid that, we have very strict condition when fallback is activated. And it's activated when gRPC service needs a resource that it don't have. So for instance, if gRPC service knows that, oh, I need to talk to some new service, and that new service is in some cluster. So it knows from the higher level xDS resource that this cluster should exist. It will ask configuration server for that cluster information, but configuration server may be down. So in this case, gRPC will start fallback process. So it will basically forget all the previous information. Well, not forget it, yeah. But it will establish connection to the fallback control plane, and it will try to reconstruct the complete configuration from top to bottom. So it will ask for the top level resource, then it will ask for resources referenced by that resource, and so on. It will go down, and it will start using information from fallback server, and no resources from the primary server won't be used. And obviously, if it's a new instance, a new service is being spin up, then it will start using fallback information from the beginning because it has no information from the primary server. So this ensures consistency and also can bring down the control plane. Also, it can bring down the fallback control plane if they're too eager. Yeah, so while we are using information from the fallback control plane, we will keep trying to reestablish connection to the primary one. Because as we established, we trust primary control plane more. We expect it to have better data, more up to date and better updated and so on. So we will keep token to the primary control plane while using fallback information. And once we reestablish connection to the primary control plane, we will start downloading the configuration from the primary control plane. But while we are downloading that configuration, we will keep using fallback configuration from the fallback server. So it's because sometimes when you are restarting services, they don't come up as you expect. So there may be some extra outages, and we don't want to disrupt the working of the server. So only once full configuration from the primary control plane is available, only then we will switch to using that information. So when we are switching to fallback information, then the moment we trigger the fallback, the moment we request the resource and the primary control plane is not available, we start using fallback information. But for the primary, we will only start using primary information when we know that we have the full config. So, and obviously the important question is how to use it. So this is implemented inside the gRPC. So hopefully there is not much that needs to be done in the actual gRPC application. So all that is needed, the big ask is a secondary control plane that should be available. And other than that, just another server information should be added to the bootstrap file. And after that, any xDS-enabled gRPC service will be able to switch to fallback to secondary configuration servers. That's what.
When it reconnects to the primary, how frequently does it check? Are we talking seconds or?
So it uses gRPC connection. So it will use all those like regular. Sorry, I forgot the terminology, but
It'll start at a few seconds and then do exponential back.
yeah, that's what I was trying to remember. Exponential back off, yes.
You look for the primary.
It'll
Yes.
continue to look for it, but
So the xDS protocol.
back off the longer it's down, the longer.
So the xDS protocol is just gRPC. So it will behave same as any other gRPC. It can have the load balancing and so on.
I have one question. So let's say that we have 5 services. Just so which means that the one service can talk to the other service.
I'm not sure everyone.
Yeah, I think it's okay. So I mean that let's say we have 5 services and you have a service mesh. So which means that the one service to talk with another service, it should always go to the service mesh, get the configs, and then go to another service. Is that?
So it caches the configuration. So ideally, if it needs to talk to some new service, it will ask the configuration server for the xDS resources, and then it will use the cached information as long as possible. So xDS protocol, it pushes, it's push, it's not pull.
Oh, okay. So if let's say the config is updated in the XDS,
Yes.
then it will be pushed to the service.
Yes.
So which means that on the service side, each service will store the config file that is received from the XDS, correct?
Yes.
And,
So,
and the connection from XDS to the service is gRPC connection.
yes.
Okay. So what is the, okay, that is irrelevant then. I think that how the authentication is handled.
It's specific to the control plane. It's specified in the bootstrap file.
Yeah, makes sense.
So the idea is the bootstrap file gives you the information you
How
need, including authentication, to connect to the XDS server with this traffic director. Once that connection is established, then gRPC is changing.
Okay. So yeah, if that is pushed, then that makes sense. Okay.
Yeah, so those resources are pretty small, so the cache size is not that big.
I was mainly, actually, I was more like trying to follow up with the slides, but I thought how if you change the config, how the service will know that each service will know that there is a update in the config and it should be updated. If it's pushed, then that makes sense.
So to get the resource in XDS, you don't get the resource technically, but you subscribe to the resource.
Okay.
So your service will say that, okay, I need to get LDS for some other service, so say user service. So it will subscribe, and then it will get updated whenever that listener LDS resource is updated. Yes, sure.
So this question might be outside of what you've looked at on the gRPC side, but when I hear there's a fallback control plane, and control planes fundamentally know about all of the services within the mesh, I think there must be some level of shared fate between those two control planes. So we're assuming that really only some portion of the primary control plane has gone down. So really the design of that secondary control plane, that fallback control plane, sounds very interesting to me. Do you have any details on, like, for example, Cloud Service Mesh's implementation of the fallback control plane?
No, not at this time.
Okay. No comment.
Interesting question.
You have similar answers?
Yes, probably.
Phrase them a little differently. So is this on? So I guess the first question is anybody doing this, and
Yes.
who is doing this? And well, go ahead.
Yeah, so there is a Google Cloud product called Traffic Director, and there are people who use it
So
to
does
store
Envoy,
and maintain the configuration of the service mesh.
does the Envoy Bootstrap configuration support backup service, backup XDS?
I think so.
And
Envoy as well.
Oh, yeah.
Progress.
Yeah, my understanding was when Traffic Director announced that they were supporting the backup control plane, both on.
I would expect that it's still-
Started using.
so those APIs, the control plane is just an API.
Mhm.
And I could run that API server behind the load balancer with failover.
Yes.
So why
But-
would I need something else besides?
So this was
running-
mentioned that this is
that.
for extreme circumstances when the whole control plane, like bad config, is pushed or something. Because it still happens, and the impact may be very significant. Because, so as I mentioned, service mesh does not have to be in the cloud. So you may have devices in the field that actually feed from the same configuration, and then the outage may be really significant.
So some details about, so we talked, second slide or so, talked about the existing clients. They'd mostly be okay. And then you had new clients that those would just be, they have no clue what's going on. So gRPC, whenever you create the channel, it gets all this information. And from that point forward, it's pretty unlikely that it would need to fail over. There's some possibilities, but it's very, very unlikely. And you'd be doing some stranger configuration to do that. So you're really, really talking about either new clients or you're just really dynamic for some reason. So I think it goes back to how is your secondary designed such that for some reason you think it was not be a shared fate. So the simplest form is you just have snapshots of your primary, store them in some highly reliable storage that you just very, very basic, like you can read files. Hopefully things are not that messed up that you cannot read network files. So in that case, you're okay. Now everything that's connected got the most recent version already, but then any new clients, they'll get a stale version to some degree, but you're hoping that's better than nothing. And that's overall a win. But you could also have just a simpler secondary that doesn't do as many things. So every sort of feature like that it's doing, maybe that has an extra dependency. So maybe it just drops that dependency and ignores that feature. And so that would also be a possibility. Now, ideally, the primary, if it had the problem with the dependency, it would ignore it itself. But systems are complex, and so you get to figure out how you want to do it. But those are sort of two general ideas that we assumed while making the feature.
So what mechanism do you use to determine that the primary is down? Is it just connection failures, or are there some class of application errors that you would determine to mean that the primary is down?
So first of all, it can be just gRPC connection error. But also another thing is that, so it's something like we didn't receive resource on time. Because when you subscribe to resource, and if server does not have the resource, it's not guaranteed that it will say that it does not have resource. So we have to wait for some time before we decide. So if connection is broken within that timeout, then we assume that the control plane is down.
So like not found errors, but just per resource timeouts.
Yeah, so we have that 20
Right.
seconds, I think. I don't know if it's just traffic director or if it's in general. So Yash?
So back to the previous question on how we expect users to configure this. So are we expecting, so let's say my control plane is Google's traffic director, and I don't trust it enough. So before I push any configuration to traffic director, I keep a local backup copy of it so that when traffic director fails, I somehow route it to my local configuration.
My understanding is that traffic director will provide you spare control plane, just with different guarantees and different capacity.
A spare traffic, like, do we have more details on like what that looks like?
I think
Snapshot of itself, put them in non-volatile storage, and then a secondary endpoint that is much simpler has access to those snapshots, xDS snapshots.
Huh.
Paraphrasing what Eric just said.
It was one of two options. I think they.
yeah. So if you're using a third-party solution like traffic director, then you don't really have to care about that much. But if you're deploying it yourself, then you don't need to figure it out. So there are some examples in Envoy code base or some configuration servers that can be used.
And I think it does really matter what modeling you're expecting for the failures. For example, let's say there's a config of death that for some reason someone uploaded some config and it's just causing everything to fail, causing the primary to just die. Well, simply delaying the config rollout for the secondary gets you some benefits there. So it really depends on your error model, exactly what you're expecting and what you're protecting against. But the expectation here is that there's something really bad that happened with the primary, because most things load balancing can handle, and services have dealt with that sort of thing for a long time. So this is a disaster sort of idea.
So this is really features that we hope nobody will ever use.
So comparing it to a simple failover where there's no configuration required on the bootstrap file or any changes required to gRPC itself, like just imagine traffic director itself managing, like it detects that the primary failed over and somehow switches to the secondary. Like how do you compare the two solutions?
So your bootstrap will contain how to connect to the services. So bootstrap does not change after you start your service. So if that was the question.
So you're saying, why don't you have the load balancer deal with the primary to secondary switchover? So
load balancer already uses, so we already use load balancer when you talk to traffic director, for instance, if you use that as an example.
I think it goes back to the idea that the primary has better data. So you have a lot of clients that are actually working. You would hope the vast majority of your clients have the data they need. Nothing really needs to go on with them. But you still have the new ones that are coming up. And you don't want to just be dead in the water where you can't restart services and things like that. So if you just had a simple proxy make the decision, it would give out the worst data to everyone, to all the clients. Here instead, because just the clients detect when they're in a bad situation, they can get the lower quality configuration and proceed, and most of the services won't even see any impact at all because they had the good cache data. It's only the new things or someone who's doing something weirder that gets the lower quality data.
I'm sorry, I want to clarify, maybe I did not understand it correctly. So you said that, so you configure your XDS and it's a push, so meaning that whenever config changes, updates or whatever, it's pushed to the services, right?
Yeah.
So in case of the fallback, so it means that it's not pushed back to the services. So which means that the services are expecting some health check or something like that, meaning that the push once in a while, right? Correct.
So it uses gRPC channel. So gRPC channel will be broken. So
Okay.
gRPC will detect the broken channel.
So then it means that on each service side, you have to
We have an open connection.
yeah,
yes.
you have to keep you have an open connection with your service mesh.
With the configuration, with
And
the control plane, yes.
When do you know that the primary is broken? So you have to go to the fallback.
So in general case, when you start your xDS enabled gRPC service, like on start, it wants to talk to something else. So it will read the bootstrap file, it will establish the connection to the xDS configuration file, and it will get all the resources.
Okay.
So
Subscribe all the resources.
subscribe,
Okay.
yes. So at that point, if the control plane goes down, then that service will notice the broken channel.
How it will notice it exactly?
That gRPC
Okay.
two-way channel. So there will be an error when it's trying to read. So it's trying to get the notification
Okay.
from the server
Mhm.
for the push.
Mhm.
And then the channel will just be closed, and then it knows that.
So then it will go to the fallback?
So again, it will only go to the fallback if it needs some information that it doesn't already know. So for instance, imagine you have a service that talks to the user services all the time.
Mhm.
So it starts up, it gets all the configuration how to talk to the user service.
Mhm.
From this point on, even if the control plane goes down, it knows how to talk to user service.
Mhm.
But suddenly it needs to talk to address service.
Mhm.
And it does not know how to talk to address service, for instance.
Okay.
So then it will see that. It will try to ask control plane for address service. It will see that control plane is not available.
Mm.
So this is when it will try to talk to fallback and get configuration information for both user and address services.
Got it. Interesting.
Well,
It's a bit complicated, but
Hmm?
I'm just thinking if I would design that myself, how would I do that? It looks a bit complicated, maybe. Yeah.
So this is it matters to users, to our users with their meshes and the availability.
I remember I haven't used much microservices. I used gRPC earlier, but not in context of microservices, just, for microservices, we use config service, but it was a Spring application. We use config service, and I don't remember exactly how. I never dig into that, how it works under the hood, but I don't think it was that much complicated.
Yeah,
If I could add a comment to the complexity thing, I like to think of XDS as being just really fancy DNS, right? Like if you describe the process of DNS, it's actually kind of complicated, the caching logic, things like that. The design choices behind XDS, in the simplest case of service discovery, they solve a lot of those DNS issues, right? Like you're actively push down update from the control plane rather than having to keep track of the TTL and then pull and then make sure that you have caches across your entire system at whatever scope that you want to maintain caching. I think if you inspect it just in the service discovery case, you actually see that it's simpler than DNS. Of course, there are additional use cases that are supported here. Like we'll do traffic splitting based on your paths, based on your headers. We'll do weight-based splitting, which is none of that stuff is something that DNS does. But still, the overall data model, it actually is relatively simple. And I think the trick here is not to say XDS isn't complicated. It's just DNS is also pretty complicated, and we tolerate it.
If you compare with the DNS, that's top of the mix.
Yeah.
yeah, but also there is a question of scale. So as I said, it can be devices in the field. So you may have a large number of services, of clients that need to talk. So this control plane, it needs to support that scale. And it may be geographically distributed company with offices all over the world. So this is all the stuff that XDS control plane supports.
Also, does it have, is it only in the cloud or it has like an open source version?
So this is open standards.
I've never, I mean, I've been in the Google.
So Envoy is very popular.
We use gRPC, but I never heard about XDS.
I think Envoy originated from Uber, right? Or Lyft. Car share company.
Lyft never gets the credit.
Yes. Yeah, so the standard originated outside of the Google.
Okay.
The marketing isn't good, but the technology is.
I will try it, definitely.
No, it's more expensive than last I tried from SFO.
No, like me.
XDS, not Lyft.
Oh, okay. No, so that's why Uber. Okay. Yes, thank you.